Hello friends, let us look at another problem of missing readings. In this problem, one length and one angle is missing. So obviously, in this problem, one length could not be measured, maybe because there was an obstruction in chaining, could be something like a pond, lake, river, anything of that sort, but finding the angle was possible. And in another case, finding the length was possible, but finding the angle was not possible. Maybe the two stations were not directly visible. There was a obstruction in between. Maybe there were woods in between. Okay, wooden trees. The trees were present over there, or maybe a hillock or something like that. So measuring the length was possible, but direct observation of the two stations from one end to the other end was not possible. So finding the angle was not possible. So over here we have the following data is of a closed traverse. Compute the missing quantities. The length of AB is unknown. The whole circle bearing of AB is 30 degrees. That of BC, the length is 2250 meters. The angle, the whole circle bearing is 130 degrees. The length CD is 1330 meters. The angle is unknown. The length dA is 2 kilometers, that is 2000 meters, and the whole circle bearing is 320 degrees. So as mentioned earlier, let us be very clear that whenever we don't have a quantity or more than one quantities, then the closing error we cannot get. So the accuracy cannot be checked. We only work on the presumption that, or on the assumption that, all the readings whichever have been taken precisely. All the lengths as well as angles have been taken with utmost precision. That's how we have got this. So now let us proceed to find out what is this unknown length and what is the unknown angle in this precisely done closed traverse. The first step, as usual, calculate the latitudes and departures of all the lines. Whatever is unknown, for the length assume a variable, say L, and for the angle assume another variable as theta. So the length of AB is assumed as L and the angle for C, that is the line CD, is assumed as theta. Now putting in this table, we have for the line AB length as L, the whole circle bearing as 30 degrees. The latitude we know is L cos theta, so it is L into cos of 30 degrees, which gives me the answer as 0.866 L. Okay, that is plus 0.866 L, which tells me that latitude is in the north direction. It is a northing. Departure, length into sine theta is departure, so length is L sine of theta, sine of 30 degrees, so that gives me the answer as plus 0.50 L. So plus tells me that this is in the east direction, or it is easting. Coming to the line BC, we have the length as 2250 meters, the angle as 130 degrees. So we have latitude, which is L cos theta, which is equal to 2250, that is the length, into cos of 135 degrees, that comes to equal to minus 1446.27 meters. Minus tells me that it is southing. So the latitude of BC is southing of 1446.27, or latitude of BC is equal to minus 1446.27. The departure is L sin theta. The length is 2250 into sine of 130 degrees. There is a small typing error over here. 130 degrees. Okay. So the answer is plus 1723.60, which means the departure is easting. It is on the east side, 1723.60. So departure of BC 1723.60. Coming to CD, the length is 1330 and the angle is unknown. So we will use it as it is. Latitude is L, that is length cos theta. So L is 1330 into cos of theta. it will remain as it is. Similarly, departure L sine theta. L is 1330 into sine theta. dA, that's the last line. Length is 2000 meters. The angle is 320 degrees. So latitude is L cos theta. So 2000 into cos of 320 degrees. So we get the answer as plus 1532.09. So the latitude of dA is 1532.09, or it is nothing, 1532.09. Coming to the departure, departure is L sine theta. So L is 2000 into sine of 320 degrees. So the answer is minus 1285.58. The minus sign over here tells me that departure is in the west direction. It is a westing of 1285.58. So what we have done is, in the step 1, we have calculated all the latitudes and departures by considering some of the values as unknowns. So having that done, we have got all the values. Let us go to step number 2. In step number 2, as usual, obtain the sum of all the latitudes and that of departures. So latitude, the first one is plus 0.866 L, then minus 1446.27, then 1330 dot cos theta or into cos theta, and plus 1532.09. So sum of all the latitudes plus 0.866 L minus 1446.27 plus 1330 cos theta plus 1532.09. Similarly, all the departures plus 0.50 L plus 1723.60, then we have plus 1330 into sine theta, and then we have minus 1285.58. Getting them together, plus 0.50 L plus 1723.60 plus 1330 dot sine theta into sine theta it is, and minus 1285.58. So we have got all of them together. So having got the second step done, that is obtaining the sum of all the individual latitudes and that of the departures, we go to step number 3. In step number 3, the sum of all the latitudes as well as the departures should be equal to 0. So putting the sum of all the latitudes and departures equal to 0 over here. So from here, when I solve, I've put all this equal to 0. So this remains and this remains over here. So all the things I get on one side, I get all the terms on one side. What I do is I move this value, I move this value, and I move this value. Only I keep 133 into cos theta on the left hand side. Rest all the terms I move on the right hand side. Having done that, 1330 which is multiplied to cos theta, it comes in the denominator. So cos theta becomes equal to minus 85.82 plus 0.866 into L, the whole thing upon 1330. Please note 1330 was multiplied by cos theta. So when I move first term, second term and third term on the right hand side, the second term and the third term, they can be added or subtracted as the case may be. So we have only two terms on the right hand side and the whole thing gets divided by 1330. That becomes my equation number 1. Remember, the whole thing comes in terms of cos theta. Second thing over here, the second equation also, the equation of the departures, I put equal to 0. And in this case, I keep only sine theta on the left hand side. All the rest terms, the first, second and the third term, I move on the right hand side. When I move them on the right hand side, this term, the second term and the fourth term can be added or subtracted as the case may be, and then they are on the right hand side. So the only term which is multiplied to sine theta is 1330, that goes in the denominator. So we have got two equations, one equation in terms of cos theta, second equation in terms of sine theta. This is a very important relationship which we have got. First equation in terms of cos theta, second equation in terms of sine theta. Having got equation number 1 and equation number 2, we go to the next step. In the next step, take the square of the left hand side and add up the equations. So left hand side was cos theta, so that becomes cos square theta will be equal to the whole right hand side square. Similarly, sine theta becomes sine square theta becomes equal to the whole right hand side square. Now adding this cos square theta plus sine square theta gives me to add the right hand side also. So I have added the left hand sides cos square theta plus sine square theta will be equal to this whole term plus this term plus this term over here. What is sine square theta plus cos square theta? Sine square theta plus cos square theta is 1. So left hand side is 1. Now I can expand this. This becomes a plus b the whole square. I can easily expand this. Similarly, this one I can expand. If I expand and if I solve them, then I get one quadratic equation of the whole thing. Getting all the terms on one side, I get the quadratic equation from here. L square plus 581.46L minus 1569668.3 equal to 0. That's a quadratic equation. Solving this quadratic equation, we get the answer length equal to 995.424 meters. Please note, solving this quadratic equation, we get the value of length as 995.424 meters. So what we have done over here in this step, please note this is a very important step. We have got the square of cos, we have got the square of sine, we have added them together to get 1. In this we have eliminated theta. Theta is totally gone from the equation. There is only one unknown, which is L. Solving the equation for the squares a plus b the whole square, a plus b the whole square, solving them together, adding them together, we are left with one quadratic equation, that is L square plus 581.46 L minus 1569668.3 equal to 0. Solving this quadratic equation, we get the length value as 995.424 meters. So we have solved this problem in order to find the length. Still, theta is unknown. We need to find theta. Let us proceed further. Now, substituting in equation 1 the value of L. Now that we have got the value of L, in equation 1 we put the value of L. We get cos theta as minus 0.7126. For which angle is cos theta minus 0.7126? There are two values. Theta can be either 135 degrees 25 minutes or it can be 225 degrees 25 minutes. So one of them is true. Both cannot be true. So I take the value of L, substitute that in equation number 2. When I substitute in equation number 2, I get sine theta as minus 0.707. Now for which angle is sine theta equal to 0 minus 7, for which angle is sine theta equal to minus 0.707? Theta is equal to 225 degrees 25 minutes or 315 degrees 25 minutes. Now which is the one which is common between the two? It is only 225 degrees 25 minutes. Therefore theta is 225 degrees 25 minutes. That's the way we solve when we have the two unknown quantities in which one is length and one is theta. Please note, when one is length and one is theta as the unknown, we have to solve for cos theta, we have to solve for sin theta, square them up, add them up. Cos square theta plus sin square theta is 1. We get the variable only as L. We will be getting the value of L. Having got the value of L, we can substitute and get the value of theta. That's the way we solve it. Thank you.